Let's go over the big three of object-oriented programming. We're actually going to talk more about encapsulation here, but we need to get through the definitions of the first three in order to start talking about encapsulation. Encapsulation is actually hiding the details of the internal implementation when you're talking about object-oriented programming. So we'll see what that is. We've already looked at it. We'll get more into the details. Inheritance is code reuse in talking about the building block strategies. Polymorphism is similar objects that can be of many forms. So these are the high levels, and this makes up object-oriented programming, OOP. Well, what exactly is OOP? OOP allows groups of objects to cooperate with each other by exchanging data, messages, and a logical framework. And this is going to achieve a common, simple, or complex goal. That's the high level of what it is. Notice that we're talking about cooperation of objects and exchanging data and messages, as well as that logical framework. Objects are software constructs, and this is going to encapsulate data and then allows us the ability to actually use and modify this data, as well as share the data with other objects. So that's object-oriented programming from a definition standpoint. It can be very complicated. We can describe things in an organized way, so it makes things a little bit easier. Encapsulation actually is going to be the first thing we're going to talk about, and it's going to allow us to jump into the other ways of working with object-oriented programming, and it really deals with how you handle and you manipulate an object-oriented language to follow the rules. So we're following rules, and we're doing things from the standpoint of what the compiler wants at compile time and what we can do at runtime. So it starts with encapsulation. So encapsulation is going to hide the details about how our objects are going to work from the actual object user, whoever's using that object, that class, whatever is going to reference another class. The details are going to be hidden. And we're actually hiding the implementation. So if that implementation changes, no one's going to know about it because it's hidden within that class. So we're going to be explaining what our implementation is actually doing with our data dictionaries and our documentation, as well as the method signatures, so we know what to pass to those methods. So we're working with state data here, which is our instance variables, and you should declare those variables private. This is going to ensure that things are hidden. And then we're going to actually work with methods to give access to that or properties. So encapsulation, totally private. You got your signs up, keep out. Another analogy could be you can have a bank account, but you can't go into the vault. So think of it that way. You can queue in line, you can talk to a teller, but you just can't walk into the vault. Would be nice. And like I said, you're going to use properties to protect your classes with that state data. You're going to protect the state of your class. And also, we're going to access our data via public methods, like I mentioned. So let's take a peek in Visual Studio. And we're actually going to take a look at the primal code. I think it's easier to look at it that way. You could look in Visual Studio if you don't have primal code. There's an encapsulation project there within the object-oriented folder. You can take a peek there. It's easier to look here. So this is encapsulation just to show you that we've already done this. This is a project that we looked at earlier in classes. We're going to use our properties here, and using the get and set with our properties is going to allow us to access our private member data here, our private members, our fields. So we have this set as private, there's shorts, x is equal to 0, y is equal to 0. That's initializing things. And then to give access to the outside world, we create a public property or a public method. Same type, except we're using capital X. You can change the name to whatever you want. It is case sensitive, so capital X is not lowercase x. So we get the value here. We're just returning x to our user, whoever's using our class. And then to set the value, we use this type of nesting here to get that to work, get and set. We talked about this earlier in properties. For setting, we're going to test the values to make sure they fit within our range. And then we're going to use x is equal to value to pass that value, which is just a keyword, back to our variable. X is equal to value. Value is what the value of our x is when it gets passed in. Very nice and easy to work that way. You can take a peek at it. Same thing for y, same syntax. You're doing your tests in your set. And then later on, when we use this all the way down in the main entry point, you can see we access. This is a class dot capital X is equal to 90, C1.y is equal to 20. So we're setting those values, and then we can reference those values, bring back the value, and use it within that type, whatever type that is. So that's where we're referencing things. And also here, C1.x or y.